Day 376 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3341. Find minimum time to reach last room 1. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. There's a dungeon with n times n rooms arranged as a grid. You're given a 2D array move time of size n times n, or n times m, where move time I and j represent the minimum time in seconds after which the room opens and can be moved to. You start from the room 0, 0 at time t equals 0 and can move to an adjacent room. Moving between adjacent rooms takes exactly 1 second. Return the minimum time to reach the room n-1 and m-1. Two rooms are adjacent if they share a common wall either horizontally or vertically. All right, y'all, so I can understand how this question could be difficult to understand. So let's go ahead and take a look at these examples just to make sure that we're doing this problem correctly. So in example 1, we have the input move time equals a 2D array, first array being array of integers 0 and 4, second array being an array of integers 0 and 4. The output is 6. Explanation says the minimum time required is 6 seconds. At time t equals 4, move from 0 to room 0, 0 to room 1, 0 in 1 second. At time t equals 5, move from room 1, 0 to room 1, 1 in 1 second. So even that's a little bit difficult to understand. So let's break it down one step further so I can show y'all what's going on in this example. So first thing I'm gonna do is I'm gonna copy and paste these so you could get a better visual representation of what's going on. These right here represent the time that it takes to move from each room, but these are not the rooms themselves. The rooms are on a grid, n by n grid, so we can make the rooms look something like this. We could say, let's say the ones with the parentheses, they represent the rooms. So room 0, 0, it's a 0 right here, right? So this means it takes 0 seconds. We could start right there with room 0, 0. Boom. Then we have over here, we can have room 0, 1. Boom. So this right here, this 4 right here represents the amount of time it takes before we can move to room 1 or room 0, 1, Then down here we'll have room 1, 0, and this right here corresponds to the amount of time we need before we can move to room 1, 0, so we're going to have to wait 4 seconds. And here over here at room 1, 1, this represents the amount of time we're going to need to move to room 1, 1. Boom. So these right here are the rooms. This is just the moving time that we got from right here. So we start right here, room 0, 0. We have to wait 4 seconds before we can move to any one of these rooms, right? So we wait 4 seconds. Say we wait 4 seconds and we move. It says at time t equals 4, we move from room 0, 0 to 1, 0. So we could come right here. Boom. We wait 4 seconds because the time right here requires us to wait 4 seconds. So we wait 4 seconds, then we move right here. Boom. So now we're 5 seconds in because remember, it says right here, it takes moving between adjacent rooms takes exactly 1 second. So we have to wait 4 seconds. Then after 4 seconds, we move right here, and moving right here is going to take 1 second. So altogether, that's 5 seconds. Now, since we've already waited 5 seconds in total, we already waited our 4 seconds. We don't have to wait an additional 4 seconds to move from room 1, 0 to 1, 1, right? So we already waited, or 5 seconds has already passed between us moving from this room to this room. And so since this only requires 4 seconds and 5 seconds already passed, we don't have to wait an additional 4 seconds to move to this room. We could just move to this room right here because 5 seconds has already passed. However, moving from this room to this room is going to take an additional 1 second, right? Because moving between adjacent rooms takes exactly 1 second. So we went from this room, we started at this room, we waited 4 seconds, 4 seconds passed, we moved to this room. That took 1 second. Now we're at 5 seconds. Then we moved from this room to this room because 5 seconds already passed, so we don't have to wait an additional 4, and that's going to take an additional second. So once we get to this room, all in total, it took 6 seconds, and that's why our output is 6. Now, just in case that didn't make sense to y'all, we're going to go through the rest of the examples as well. So let's go ahead and take a look at example 2. So in example 2, it's a little simpler. We have the move time equals the 2D array of integers. First array being 0, 0, 0. Second array being 0, 0, 0. Again, this time the output is 3. Explanation says the minimum time required is 3 seconds. At t equals 0, we move from room 0, 0 to room 1, 0 in 1 second. At t equals 1, we move from room 1, 0 to room 1, 1 in 1 second. And at t equals 2, we move from room 1, 1 to room 1, 2 in 1 second. So once again, let's come over here. Let's break that down so we can make it make sense for everybody in case that doesn't make sense, because this is a confusing question for sure. So boom, once again, this is the move. This represents our move time grid. Then we need to update this. So update the room. So for that, we could just come here, boom, come here, boom. That's our grid. Now this right here, room 0, 0, 0, 1, 0 seconds. So we could just delete this, put 0. Same right here, 0. Same with this room, so that's a 0. They're all 0, so they all take 0 seconds. So boom. So once again, these represent the amount of time we have to wait before we can move to each room. So that's where all these zeros with next to the equal sign come from. They come from, all of these zeros come from right here. Boom. Now, since we don't have to wait any seconds, for move time, we could start right here. We could wait 0 seconds. Then we have to move right here. Boom. But it still, remember, it still takes 1 second to move between adjacent rooms, right? So we move from here to here. That takes 1 second. Boom. Then where does it say? Then we went from 1, 0 to 1, 1. So we move from here to here. That takes another second. So right now in total, we're at 3 seconds. Sorry, y'all. This should be room 1, 2. And this should be room 0, 2. But okay, so we move from here. We move from here to here. That's 1 second. Then we move from here to here. That's another 1 second. But in total, that's 2 seconds. Then we move from here to here. And in total, that's 3 seconds. Boom. So our output is 3. So that's how we got the output of 3. Okay, we have one more example. Let's just go through it just to make sure it makes sense to everybody. So we have in example 3, we have our input move time equals a 2D array. First array being 0, 1. Second array being 1, 2. The output is 3. Boom. So let's see how they got that output. So let's go ahead, create our move time grid over here. Boom, put that like that. Boom, come right here, put that like that. Now we need to create our grids, so we could just copy and paste this. That's our grid, our starting grid. Sorry y'all, boom, that's gonna be equal to 0 because it's a 0 right here. That's the amount of time it's going to require. Then we could come right here, this is gonna be room 0, 1. We come right here, that's gonna take 1 second because that's how much time it requires. Then we come right here. This is going to be room 1, 0, and that's going to take 1 second. So we put a 1 right here. Then we come right here, and this is going to be room 1, 1, and that's going to take 2 seconds. Boom. So we set that equal to 2. So we start right here at 0. Room 0, 0. We have to wait 1 second before we can move here, right? So we wait 1 second, boom. Then we move here. Now we're 1, 0. and it took an additional second to move. So we waited 1 second because it requires 1 second before we can move. Then after that 1 second passed, now we can move, and it's going to take an additional second to get to this room, right? So now we're at 2 seconds. But this requires 2 seconds, right? 2 seconds is already passed, so we don't have to wait an additional 2 seconds. We could just move from this room straight to this room, and all together, that's going to take an additional 1 second just to move from the room to room. So altogether, that's 3 seconds. So once again, we have to wait 1 second before we can move to this room or this room. Wait 1 second, boom. Now, clock start, we could go. We moved to this room. That took 1 second to move to this room, so now we're at 2 seconds total. This requires 2 seconds to move before we could move, but we're already at 2 seconds, so we don't have to wait anymore. But it still takes 1 second to move, so then we move from here to here, and that's going to take an additional second, and in total that took 3 seconds, and that's why our output is 3. Now, I know that was a confusing question to understand, but hey, we made it, we got through it, and now it's time to get to the fun part, the actual code, y'all. Code's not that difficult, so I hope you're excited about it. Let's get started. Now, the first thing we're going to do is we're going to come outside of this class, come up here, and we're going to create a struct representing a grid cell with its coordinates and distance time to reach. So for that, we could just create our struct. We could call it item, say colon, comparable. Then we're going to open up the brackets. We're going to say let R colon, that's going to be an int for the row index. We're going to say let C colon, that's going to be an int for the column index. And then we're going to say let dist colon, that's going to be an integer as well, and that's going to be the time to reach this cell. Then come right here, and we're going to, for comparison, for priority queue and our minimum heap that we create based on distance, we're going to say static func is less than, open up the parentheses, LHS colon item, comma, RHS colon item, and it's going to return a Boolean. Then we're going to open up the brackets. We're going to say return LHS.dist is less than RHS.dist. Boom. Now we can get into our class. Let's start with our class and our function, right? Now the first thing we're going to do, we're going to say let n equal move time dot count, and that's going to represent the number of rows. Then for the columns, we're going to say let m equal move time square bracket 0 dot count, and that's going to represent the number of columns. Then we're going to say let dirs equal, then we're going to open up the square brackets. We're going to say open up the parentheses 0, 1, come outside of that parentheses. We're going to open up more parentheses, and it's going to be 0, -1, come outside those parentheses. We're going to open up more parentheses. We're going to say 1, 0, come outside those parentheses, open up more parentheses. We're going to say -1, 0. And this is the 4 directions, right, left, up, and down, that we're going to need when we're moving through the columns. Now we need a 2D array to store the minimum time to reach each cell initially set to max value. So for that, we're going to come right here, declare a variable called DARR, and set that equal to an array, open up the parentheses, repeating, colon, an array, because it's a 2D array, so it's going to be repeating arrays, then open up parentheses, and then we're going to say repeating, colon, int dot max, comma, count, colon, m. We're going to come outside of this parentheses, but still inside the other parentheses, we're going to say comma, count, colon, n, just like that. Now we need our visited array to mark the cells that we've already processed. So for that, it's going to be similar to what we just did. We're going to declare a variable, and we're going to call this, or excuse me, first we need our starting cell. We need to set our starting cell as 0 times. So we come right here and we can say DARR square bracket 0 square bracket 0 equals 0. So that's just to set our starting time for our 0, 0 room. Boom. Now we're going to come right here. We're going to say visit, and we're going to set this equal to an array. Open up the parentheses, repeating. It's going to be another 2D array. So we're going to say repeating, colon, array, parentheses, repeating, colon. This time we're going to say false, comma, count, colon, m. Come outside the parentheses, we're going to say comma, count, colon, n. Boom. Then we're going to mark our first room as true. So we're going to say visit square bracket 0 square bracket 0 equals true. Boom. So we're going to mark the starting room as we've already visited it, because that's where we're starting. Now we need our min heap priority queue to process the next cell with the least time. So we can declare a variable called heap. We'll set that equal to a heap less than item greater than, put the parentheses. Boom, just like that. And we're going to say we need to start from 0, 0 at time 0. So we're going to say heap.insert. Then we're going to open up the parentheses, and we're going to say item, open up more parentheses. We're going to say r colon 0, comma c colon 0, comma dist colon 0. Boom. Now we're not done yet, because we need our main loop to process cells in order of earliest arrival time. So for that, we come underneath this heap part right here, and we're going to say while let cur equals heap dot pop min parentheses, open up the brackets. We're going to say for, open up the parentheses, dr comma dc, come outside the parentheses, and dirs. We're going to open up the parentheses. We're going to say let r equal cur dot r plus dr. Boom. Then we're going to say let, and that's going to be the new row. Then we're going to say let c equal cur dot c plus dc, and that's going to be the new column. Now we need to check if RC is within bounds and has not been visited. For that, we're going to say if R is greater than or equal to 0 and two and signs, R is less than n and two and signs, C is greater than or equal to 0 and two more and signs, and C is less than M, two more and signs, exclamation point, visit, square bracket R, square bracket C, meaning R and C have not been visited. Then we open up the brackets. Boom. Now we can't enter RC before move time RC, so we have to wait if necessary, then add 1 second to move. So for that, we're going to say let D equal max, open up the parentheses, cur dot dist, comma, move time, square bracket R, square bracket C, come outside of that, and we're going to say +1. Boom. Now we need to update the minimum time to reach RC, so we're going to come right here, and we're going to say DR, and we're going to say square bracket R, square bracket C equals D. Boom, and now we need to enqueue this cell, so we're going to say heap.insert, open up the parentheses, item, open up the parentheses, R, colon R, comma, C, colon C, comma dist, colon D, and that's going to enqueue this cell. Then we need to mark visited as true so it's not processed again. So we're going to come right here and we're going to say visit square bracket R square bracket C equals true. Boom. Now we're not done yet, but we're getting there. We still need to return the minimum time to reach the bottom right cell. So for that, we come right here and we say return dr square bracket n square bracket n minus 1. Sorry, y'all, that should be a square bracket n minus 1, and then another square bracket m minus 1. Boom. Now that should be all she wrote, y'all. Let's give it a run. Hopefully it runs like it's supposed to. Let's see. Okay, we got a typo. So this should be false, not place. So let's change that. Let's run it again. See what happens this time. And it's accepted, y'all. So let's go ahead and submit it. Make sure it's still accepted after we submit it, because we all know how LeetCode can get. And look at that, y'all. 32 milliseconds beats 79.19% of users. Not too bad, not too bad at all. We'll get those numbers up as we continue down our LeetCode journey. But right now, I feel like this is a good solution to understand. So with that being said, y'all, let's make sure you get one more look at the code. That's the struct we created. This is the part of the class, top part of the class. Boom. Then we got the middle part, or actually that's the end of the class. This is the bottom part of the class. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.